Okay, here we're going to be evaluating some expressions. First example is to evaluate this expression right here when x equals 10 and y equals 7. So the first thing to do is to put these values in for x and y with parentheses around them. So if I do that, I would get 10 minus 7, and here it is worked out, 10 minus 7 over x is 10, 10 plus 5 plus 10 plus 7 over 10 minus 4. Now work this out in pieces. So 10 minus 7 is 3, 10 plus 5 is 15, plus 10 plus 7 is 17, and 10 minus 4 is 6. The 3/15 reduces down to 1/5, and now we would need to get a common denominator between 5 and 6, and that's 30. 5 goes into 30 6 times. 6 times 1 is 6, and 6 goes into 30 5 times, and 5 times 17 is 85. Now that we got the common denominator, just bring that denominator along and add your numerator, and we get 91 over 30, which is the same as, well, 30 goes into 91 3 times with 1 left over. So 91/30ths is the same as 3 and 1/30th, which if you wanted to switch this 3 and 1/30th over to a decimal, you would just take the 30 into 1, and you would get 3 point something, and you would have that answer there as a decimal, which would actually be 30.03 with the 3 repeatings, 30.0333 if you wrote it as a decimal. The next problem, we're completing this table here using this formula for Fahrenheit and temperature, or time since the person has been experiencing hyperthermia. And here's their Fahrenheit temperature. So it's asking you to plug these different values in for the T, for the time, and time in minutes that the person has been experiencing hyperthermia. So at 0 minutes, that means the person just started or is about to start experiencing hyperthermia. The moment before they started experiencing hyperthermia is T equals 0. And when you plug that in, you get F equals 0.36 times 0. We're just substituting the 0 in for T. Plus 99. Well, 0.36 times 0 is 0. 0 plus 99 is 99. Plugging the 1 in for T, it would be 0.36 times 1, which is 0.36 plus 99, 99.36. Plugging the 2 in for the T right here. We have 0.36 times 2, which is 0.72, plus the 99 is 99.72. On this next problem, we're evaluating this equation, h equals 2p minus 6. And it's giving you different values for the P here. And this is the actual hemoglobin level, but we're supposed to predict the hemoglobin level, the H, based on this equation. H equals 2P minus 6. Right here it is too. So plugging in the 10 in for P, we would get H equals 2 times 10, substituting the 10 in for P. 2 times 10 minus 6, well, that's 20 minus 6, or 14. Substituting the 20 in, we'd have 2 times 20 minus 6. We're just substituting the 20 in there for the P. 2 times 20 is 40, 40 minus 6 is 34, and you keep doing this. On the next one, we would get, well, 2 times 30 is 60, 60 minus 6 is 54, and you see how this would go here. Same type of thing here. We're just evaluating this expression. Here's the expression, C equals negative 0.4n plus 10. So substituting the 0 in for n, I would get negative 0.4 times 0, which is 0 plus 10, so I'd get 10. If I substituted 1 in for n, I'd get 1 times negative 0.4 is negative 0.4 plus 10 is 9.6. And if we substitute the 2 in for n, 2 times a negative 0.4 is a negative 0.8 plus 10 is 9.2. Here's one more, evaluating the cost to rent a apartment based on the area A. Well, we're putting in different values for A. So if the area is 500, 2 times 500 is 1,000. 1,000 plus 300 is 1,300. And you could do that for each of these. Putting in the 1,000, 2 times 1,000 is 2,000 plus 300 is 2,300, and so on. Now we'll do it. We'll take a look at more substituting with messier values, negative values, and so on in the next video.